Rational expressions. In this video, we're going to talk about least common denominators and adding and subtracting rational expressions. With me, Catherine. Let's get started. If you're in my class, after this video, complete this homework. Rational expressions part 1, complete problems 14 through 34. Let's get started. Just like adding and subtracting fractions, you don't need the least common denominator, you just need a common denominator. We're going to find it by factoring like we did when we found the greatest common factor of terms. But this time, we're going to put all the terms together. Let's look at this first example. The first thing we want to do is factor everything. And we've done this a lot, so I'm not really going to go into how I did this, but 12x equals 2 times 2 times 3 times x. And 18x squared is 2 times 3 times x. Then we're going to circle all the numbers and write it as a product. Finally, we're going to multiply them together. So first, we're going to circle all the numbers. 2 times 2 times 3 times 3 times x. Now you're going to notice, even though there was only one 2, I wrote it down. And in the red, there was only one 3, I wrote that down. And in the black X, there was only 1, and I wrote it down. Remember, we're going to find it just like we did for factoring, but this time, we're going to write all the terms down. Now we multiply them together. 2 times 2 times 3 times 3 times x, which gives us 4 times 9 times x squared, which is 36x squared. And that is our least common denominator. Let's look at another one. Once again, we have to factor everything. Well, 15y squared is 3 times 5 times y times y. Now, we have to factor 3y squared minus 6y. If you remember, we have to find the greatest common factor of 3y squared and negative 6y. So I'm going to do it over here on the right. 3y squared is 3 times y, and negative 6y is negative 1 times 2 times 3 times y. Now remember, we're trying to find the greatest common factor, so all we're going to do is circle things that are in common. And it turns out that 3y is our greatest common factor. What do we do next? Well, we're going to write our greatest common factor and a parentheses. Then we're going to divide everything by the common factor, which is 3y. And we end up with 3 times y minus 2. Hopefully you notice that I'm lining like terms on top of each other. It's really important. And now we're going to find the common denominator. We're going to circle all of the terms together, even the ones that only have 1. So we end up with 3 times 5 times y times y minus 2. That gives us 15y squared times y minus 2. And that is our common denominator. Let's look at another one. Now for this one, we have to factor all of the denominators. For the first one, I'm going to go through the process. For the rest of them, since we have been factoring a lot, I'm just going to put the answers. So for the first one, we need to multiply to negative 12 and add to 1. In this case, we get z minus 3 times z plus 4. Z squared minus 9 is z minus 3 and z plus 3. Notice I'm putting the common factors underneath each other. Finally, z squared plus 7z plus 12 is z plus 4 times z plus 3. We're going to circle, or put a square around in this case, all of the common factors. So it turns out that z minus 3 times z plus 4 times z plus 3 is our common denominator. Rational expressions. Now, in the last video, we talked about rational expressions and how they're just fractions. So when we have fractions with a common denominator, we simply add the numerators, or the tops. So for a here, all we have to do is take 7 plus 8, and we end up with 15 over 18. But remember, we always have to reduce or simplify if we can. Now let's look at another example. For this one, we have a common denominator, x squared minus 1. Just like the last one we did, we're going to add the tops. Why am I adding the tops? Because I'm adding the two fractions together. So I have x squared plus 6x plus 4x squared minus x. On the top, we're going to collect like terms. I put them next to each other because for me, that's the easiest way to see it. But of course, you don't have to. You could go right to the answer. 5x squared plus 5x. Remember, we always have to reduce or simplify if we can. Yes, we need to factor everything if we can. So let's keep looking at this one. Let's look at 5x squared plus 5x. Once again, I want to find the greatest common factor. So 5x squared is 5 times x, and 5x is 5 times x. We circle the common factor, and it turns out that 5x is the greatest common factor. That's what I have to factor out. So the first thing we do is write 5x in a parentheses, then we divide everything by 5x, and we factored it. Now we have to look at the bottom, x squared minus 1. For this one, we have to think of things that multiply to negative 1 and add to 0. In this case, it's x minus 1 times x plus 1. So let's substitute those in. We have 5x times x plus 1 over x minus 1 times x plus 1. Do you remember we have to do some canceling, or what I like to call slash? So it turns out, when we add these two fractions together, we end up with 5x over x minus 1. And that's our answer. I bet you know what's coming next. Yep. What happens if we don't have a common denominator? Well, then we have to make a common denominator. So let's look at 8/3 minus 5/7. The easiest thing to do is just multiply each fraction by the other denominator. So I'm taking 8/3 times 7 over 7, and then I'm taking 5/7 times 3 over 3. This gives us 56 over 21 and 15 over 21. Then we have a common denominator. So all we have to do is take 56 minus 15, and we get 41 over 21. We always have to reduce or simplify if we can. So does 41 over 21 reduce? Nope. And that's our answer. We're going to do the same thing with all these x's and y's and z's. Let's try one. We're going to add and write the answer in lowest terms. Now up on the top right, I kind of give us a little reminder. We're going to multiply each fraction by the other denominator. The first thing we have to do is factor both the denominators. First, to find the common multiple. A squared minus 16. Well, for this one, we have to multiply to negative 16 and add to 0, which is a minus 4 times a plus 4. 3a squared is already simplified, so we don't have to worry about that. Negative a is simplified, and then a minus 4 is simplified. So now we're just going to rewrite it with the new denominator, a minus 4 times a plus 4, in for a squared minus 16. Now here's the cool part. To find the common denominator, all we're going to do is write the denominators. See how I did that? And I lined up the common factors. Then we're going to circle everything just like we did. And it turns out that a minus 4 times a plus 4 is going to be our common denominator. Now here's the really important part. We need to make a minus 4 times a plus 4 our common denominator. Well, in the first fraction, we already have a minus 4 times a plus 4 in the denominator, so we don't have to do anything. But for the second fraction, we only have a minus 4. That means we need to also multiply by a plus 4. Remember, whatever we do to the bottom, we have to do to the top. Now notice these two fractions. They have a common denominator. That means that we can put the tops together. 3a squared minus a times a plus 4. The common denominator does not change. Just like the one we did where 21 was our common denominator, we did not change it. Yep, we're not done yet, but I have to go to the next screen. For this one, we have to do the distributive property on the top. So I take negative a times a is negative a squared, and then negative a times 4 is negative 4a. I'm going to collect like terms, so 3a squared minus a squared turns out to be 2a squared minus 4a. And we're not done quite yet because we always have to factor if we can. So 2a squared is 2 times a times a, and 4a is 2 times a times negative 1. Now some of you are going to see the common factor right away, which is 2a. That's great. Then what we're going to do is we're going to divide out 2a. So we're going to write 2a in a parentheses. We're going to divide everything by 2a, and that turns out to be the factored form. So let's rewrite it again. 2a times a minus 2 over a minus 4 times a plus 4. Now we're going to look to see if there's anything we can cancel. And in this case, there is not. That doesn't mean we shouldn't have factored, because we don't really know. There might be a common factor on both the top and the bottom. So in this case, that's our answer. Pretty cool. And yes, you're probably going to have to use a lot of paper, but that's okay. Let's look at another one. So for this one, the first thing we'd have to do is factor the denominators. Z squared minus 4, we're looking for things that multiply to negative 4 that add to 0. Well, that's negative 2 plus 2. So z squared minus 4 factors into z minus 2 times z plus 2. Z squared minus 5z minus 14. We need to find numbers that multiply to negative 14 that add to negative 5. We end up with z minus 7 times z plus 2. So let's substitute those in. Let's look at the denominators. They're not common, so we need to make them common. So just like the last one, we're going to write all of the factors on top of each other. So see, I wrote z squared minus 4 is z minus 2 times z plus 2, and then z squared minus 5z minus 14, I wrote the common factors on top of each other. Now I keep saying circle, but we're going to put a square around these. So our common denominator is z minus 2 times z plus 2 times z minus 7. Now I rewrote it with a bunch of spaces here, because for the first one, we do have a z minus 2 and a z plus 2, but we're missing the z minus 7, so we need to put that one in. In the second fraction, we have z minus 7 and a z plus 2, but we don't have a z minus 2, so we need to put that one in. Yup. Hopefully you have this written because I have to go to the next screen. All right. And now what we're going to do is just smash it all together. Maybe I shouldn't say smash, but we're going to subtract them. How's that? And the denominator is not going to change. So what I did is 4 times z minus 7, I used the distributive property. 4 times z is 4z. 4 times negative 7 is negative 28. For the second one, I had to rewrite it. Minus, in parentheses, z plus 4 times z minus 2. The reason for that is because we have to FOIL it. Yup. So what's that going to look like? Well, 4z minus 28 minus z squared plus 2z minus 8. Notice the denominator hasn't changed. Now I'm going to distribute the negative into the parentheses. This gives us 4z minus 28 minus z squared minus 2z plus 8. We have to collect like terms on the top, and we end up with negative z squared plus 2z minus 20. All right, now we have to ask ourselves, does the numerator factor? Does it? In this case, it does not, because it's prime. So this turns out to be our answer. Now that wasn't too bad, right? All right. What I want you to do is try this one. You're going to pause the video, try it, and then press play to check. All right, let's see how you did. Now we need to factor everything. In the last one I didn't mention, but the numerators 4 and z are already in simplest form, so we don't have to worry about factoring those. There will be cases when you do have to factor them. Anyway, let's look at z squared minus 4z minus 21. We're looking for things that multiply to negative 21 that add to negative 4. That turns out to be z minus 7 times z plus 3. Z squared minus 2z minus 35. For this one, we're looking for numbers that multiply to negative 35 that also add to negative 2. In this case, we'll have z minus 7 times z plus 5. Let's substitute those in. Now we have to find our common denominator, because if you notice, we have z minus 7 and a z plus 3, and then a z minus 7 and a z plus 5. So I'm going to write them on top of each other and put the like factors on top of each other too, just like we did in the last one. I'm going to put a box around all of them. So our common denominator is going to be z minus 7 times z plus 3 times z plus 5. So what I do is I make a big space, because in the first one, I have a z minus 7 and I have a z plus 3. What I don't have is a z plus 5, so I have to put that in there. In the second fraction, I have z minus 7 and z minus 5. What I don't have is a z plus 3, so I have to put that one in there. Hopefully you have this all written, because I have to go to the next screen. Now what we want to do is the distributive property on the top. Sure, we can put them together and then to do the distributive property, it doesn't matter. But 4 times z is 4z, and 4 times 5 is 20, minus z times z is z squared, and z times 3 is z, and z times 3 is z, and 3 times, oh my goodness, and z times 3 is 3z. When we rewrite it, we're going to write minus and a parentheses, z squared plus 3z. I'm going to distribute the negative into the parentheses, and we end up with 4z minus 20 minus z squared minus 3z. I'm going to collect like terms, and this gives us negative z squared plus z minus 20. Does that factor? Well, in this case, no, because it's prime. So this turns out to be the answer. How did you do? Yep, this is going to take a lot of practice. So your assignment for this video is to do Rational Expressions Part 1, and I'd like you to complete problems 14 through 34. Remember, you're going to be doing a lot of factoring, and you might not get the right answer the first time. Just relax. There's lots of times that when I do these, I don't get the right answer right away either. I have to go back and recheck everything. Usually for me, it's a positive or a negative error. Anyway, thanks for watching the video, and hopefully we're going to see each other real soon.